So I explained to you very briefly then the 5 ways in which evolution works. That is the theory of evolution. It's called the modern synthesis. Now, briefly, there are a little few things more for me to explain to you for you to get the bigger picture of the modern synthesis. So, for one thing, well, let me ask you this question. What does natural selection do? Natural selection, adaptive reproductive success. What does that do? What does natural selection do? Well, Darwinism, the theory of evolution more than 100 years ago, said, well, that does everything. Well, now we know better. We've known better for 100 years at least that there are a few different things, well, 5 different things that do all this, that make evolution happen. One of them is natural selection, and so that is part of it. And what role does it play in all of this? Well, natural selection, then, here's what it does mostly. Mostly it gets rid of bad mutations. So if you were born with one eyeball, well, you probably won't survive very well. You probably will not have adaptive reproductive success. You probably will not make babies and make it into the next generation. And you will not contribute to the gene pool, you see. So your genes will be lost from the population. So that's mostly what natural selection does. Then, bad mutations don't make it. So if you think about it then, overall, natural selection decreases genetic variability. Decreases genetic variability. There are times when you get an increase in genetic variability, you get something kind of new and strange that does well, that reproduces successfully because of a change in the environment. So that happens, but mostly, by far, most of the time, it just eliminates new and different things because usually, well, it was a bad mutation, it was a 3-legged crow is not going to do as well. So natural selection eliminates that. So then, you actually get less genetic variability, not more, because of natural selection. You can say the same thing for genetic drift. That also decreases genetic variability. So when you have small populations, you tend to start getting more sameness because of genetic drift. So in other words, genetic drift and natural selection are 2 ways out of the 5 in which evolution works that actually slow down change, mostly. More than they make new things, more changes, they actually slow it down. So evolution would slowly kind of come to a stop if all there was just natural selection and genetic drift. So then, well, what keeps it going then? What increases genetic variability? There must be something that keeps the change going on then. So what is that? Well, that is the other 3. Recombination, the reshuffling of chromosomes for animals that reproduce sexually, recombination, mutation, all these mistakes in the sequence of genes, it happens enough that we're always getting a fresh one, and some of them are actually, it turns out to be a good thing. So we're getting new and different, strange and curious things popping up all the time, also with gene flow, the same thing. So, recombination, mutation, and gene flow are the ones really that are giving us this turning over of more and more change, while genetic drift and natural selection are kind of holding it down so it doesn't change too fast, too wildly, is mostly what's happening there. That's a very brief explanation. But think of it that way and you would not be wrong. So, let me just wrap it up then, our explanation of the modern synthesis, how evolution works then. With this question, which out of these 5 ways that evolution works are the most important ones for animals? Here's your answer. All five.